Taking this question from the September 2020 KZN. In the diagram, KLMN is a quadrilateral with those coordinates. 3.1.1. They want us to calculate the gradient of LM. The gradient of LM is equals to y of m minus y of L over x of m minus x of L. The y-coordinate of m, that is a 0, minus the y-coordinate of L, that's a 1. The x-coordinate of m is a 4, and then the x-coordinate of L, that's a 1. So this is minus 1 over 3. The gradient of mn is equals to y of n minus y of m over x of n minus x of m. The y-coordinate of n, that is a 2, minus the y-coordinate of m is a 0. The x-coordinate of n, that's a 8. And then the x-coordinate of m is a 4. 2 over 8 minus 4, I'm getting a half. 3.1.2. The length of km. Okay. Notice how the x-coordinate of k is equals to the x-coordinate of m. So it means that this line is parallel to the y-axis. The length of km is going to be equals to the y top value minus the y bottom. The top value, that is it, 10, and then the bottom value is a 0. So this is 10 units. You can even use the distance formula. This is x of m minus x of k squared plus y of m, y of k squared, all of this under the square root. X of m, that is a 4, that's a 4 as well, squared, plus y of m, that's a 0, minus 10 squared. So you can see that this is a 0, that's a 10 squared, which is 100, which is equals to 10 units. 3.1.3. Calculate the value of theta. We can just construct a right angle triangle there. From the x-axis to that point, we raised by 2 units. So the y value there must be 2. To move from a 4 to an 8, I need to add 4 units. So in that triangle, tan of theta is equals to the opposite, which is 2 over the adjacent. Theta is equals to arc tan of a half this is 26.57 degrees. 3.1.4. They want the midpoint of LN. Then let's just erase that part. The midpoint will be somewhere there. And then we'll just let those coordinates be Q. So this is x is to y. So Q of x should be equals to the first value, which is 1, plus the other value, which is at 8 over 2. So this is 9 over 2. And the QY should be 1 plus 2 over 2, which is 3 over 2. Therefore, the coordinates of Q should be 9 over 2 is to 3 over 2. 3.2. Show that KL is perpendicular to LM. Okay, when we use analytical methods, if we find that when we take the gradient of LK and multiply it with the gradient of LM, if these two are equals to -1, if the product of these two is equals to -1, then KL will be perpendicular to LM. So let's take the first gradient. So this is going to be the gradient of KL. So that is going to be, let's just do this, KL multiplied by the gradient of LM. The gradient of KL, this is a 10 minus 1. And then the other value will be 4 minus 1. The gradient of LM, we already calculated, it's -1 over 3. So this is -1 over 3. 10 minus 1 over 4 minus 1, that's a 3. So you can see that the product of these two is -1. Therefore, KL is perpendicular to LM. And the reason for that is because the gradient of KL multiplied by the gradient of LM is equals to -1. And then 3.3. Prove that KLMN is a cyclic quad. Okay. If I can prove that this is equals to 90 degrees, then that is going to be a cyclic quad, because the opposite interior angles of a cyclic quad are supplementary. So now I'm just gonna calculate the gradient of MN is equals to a half. Proven. And then now we're just going to calculate the gradient of NK. The Y value there, that's a 10 minus a 2, and then 4 minus n, 8. 10 minus 2, 4 minus 8, that's a -2. So you can see that the gradient of MN multiplied by the gradient of NK is equals to -1, because that's going to be a half times -2. So this means that KN is perpendicular to MN. Therefore, when we take KLM, add it with KNM, I get 180 degrees. Therefore, KLMN is a cyclic quad, and this is because of opposite interior angles of a cyclic quad are supplementary.